Okay. In Module 1, Lesson 15, we're really discussing compound inequalities, though specifically the words and or. When we say the word and, it's inclusive. It means we have to include both things. It's more restrictive. So if we say this and this, both have to occur for it to be true. If we say something or something, it could be either one. That kind of means we take all the possible solutions and we graph all of them. So usually when we say or, we end up getting more solutions than when we say and, because and is going to be fewer. It's only where those two inequalities overlap. Another important thing to note with this lesson is that we will get inequalities that are compound, kind of pushed together. So this particular inequality says 0 is less than x is less than or equal to 3. Sounds pretty complicated, but let's split it apart. So first, I want to write it as 0 is less than x, and x is greater than or equal to 3. I don't like looking at inequalities where the variable is not first. So I'm going to reverse it. And if you reverse the order of the variable and the number, we also have to reverse the sign to keep it equivalent. 0 is less than x is still the same as x is greater than 0. If you notice, the mouth in 0 is greater than x, I'm sorry, 0 is less than x, is facing the x. And at the bottom where it says x is greater than 0, the mouth is still facing the x. It's still denoting that x is bigger than 0 in either case. And so if we rewrite it as a compound sentence, we would write x is less than or equal to 3, and, now notice we're doing and, x is greater than 0. Whenever you have an inequality where there's x in the middle and two numbers on either side, it's always going to be an and. We're taking both of those constituents and we're smushing them together. So I'm going to take this off. Okay. So here is what we decided when we split it up, what it looks like. I'm going to graph both of these two statements and see what you think. Okay, we have x less than or equal to 3. So that means I need a pen first, a solid circle on the 3. And since x is less than that 3, it needs to go this way. We also should include that x is greater than 0. Now it's not equal to 0 because there's no equals line underneath. So it's an open circle and it's greater than, so we would say that way. Where these two overlap is right there. Open circle on the 0, closed circle on the 3, and shaded in between. So where they overlap is the solution. So let me look at that solution. And that solution is that x is between 0 and 3. It cannot be 0, but it can be 3. Kind of looking at 0. So this is the solution that we're looking at. Now it asks, how many solutions are there to this inequality? Well, I could pick one. 1 is bigger than 0 and less than 3. But I could also pick 1.2765937. It's a number, it's on that number line, and it's within this boundary. In fact, there are so many numbers in between those boundaries that we can say that the numbers are infinite. And that seems to generally confuse a lot of people. Such a small little space, how can there be infinite numbers in between there? Because the inequality is including every single number, not just in whole numbers on the line. Now, if we said that x was only integers, that might change things a little bit. Or if we said x is only rational numbers, that would change things because we can include the square root of 2. Square root of 2 is in that, but it's an irrational number. So it is infinite numbers, and we can come up with tons of numbers that are in there. And with a lot of inequalities, we'll come up with infinite numbers to be solutions. It's not one number. What you have to realize is an equality will give us one, sometimes several solutions, but a certain number of solutions, and only particular solutions. Whereas an inequality will give us numerous solutions, if not infinite solutions. And this is always an interesting question as well. What are the largest and smallest possible values for x? So x is sandwiched in between 0 and 3. And the largest it can be equal to 3, but it can't be any larger than 3. So for instance, the largest possible value has to be 3. It's equal to 3. But what about the smallest possible value for x? Well, x can't be 0. So what's the number that comes immediately after 0? Is it 0.009? Is it 0.1? Is it 0.00000000009? We can get very, very close to 0 without ever actually reaching 0. So there's no possible way that we can find the smallest possible value for x. But we can find the largest because we know that it has to be 3. There's nothing larger than 3 allowed. That's what the inequality says. So sometimes we come across questions like this, but we know there are infinite amounts of numbers in between 0 and 3. And we can't find the smallest possible value because we don't know what comes immediately after 0. It's a number that we can estimate, we can approach it, but we can't get to it. We don't know what it is. We can just keep adding zeros and get really, really close to 0, but we could do that infinite amount of times.